Welcome to the ET322 how-to video for Lab 2 Diode Lab using Multisim short version where I've already built the circuits for you. Here I am in Multisim and I've created all of the diode measuring circuits with a DMM, and I will produce a video with show you how I built these. And right now let's go ahead and we'll take a look at the very first one. What we have here is a standard diode. This is a larger current diode. And let's go to view and let's zoom area. And let's turn on our simulation. And we have 0.536 volts for forward bias. It's conducting, it's forward bias. The arrow is pointing towards ground. That one's good. And let's take a look at the next one, view area. This is a standard diode biased, reverse biased, so let's turn them on. And you notice I have a ground here. That's because of the PSpice software that's working in the background that does the calculations. So it needs a reference point, so I put a ground in there. We wouldn't need that under normal situation. And it's open. Reverse bias is not current, it's not flowing. Okay, let's go back to the first batch. And let's do, this is a 1914, which is the 194148. It's a small signal diode. And let's go ahead and zoom in. Zoom area. Alrighty, so turn the simulation on. And it's 0.597, almost 0.56. That's a reasonable forward bias value for the barrier voltage. And here we have a reverse biased, and he is open. And let's go to our Zener diode. View area. And we'll do the first one. 0.49, which is reasonable for a Zener diode. This one is where we're going to have a problem. This is open. This is a Zener diode. When he's reverse biased, he should be the Zener voltage, and this is a 5.6 volt diode. And because we don't have enough voltage with our little multimeter here, we're not going to be able to do that. We'll be able to with the circuits we're going to build, but right now that's all there is. Here we're back at Multisim for our part 2 circuit. I built this using a potentiometer, and we have 12 volts going in. This is a circuit, a voltage divider, and we could provide a pretty precision voltage on here. Since we need to move the voltage and figure out what the current is, this is the best way to do that. So let's turn on, this would be our barrier voltage, or excuse me, our voltage across the diode. This would be the current through our circuit, and this is the total voltage. And I have it on DC, current DC, and voltage DC. So let's go ahead and start it. And what we want to do is we want to start and get about a half of milliamp. And so we have key A. In order to move that down, we're going to do Shift A, and we may need it to slow down a little bit, catch up. So 0.5 milliamps is going to be for 500 microamps. All right, so right now we have half a milliamp, so it is conducting. It's forward biased. This guy's acting like a diode since he's forward biased. And we're at 425 millivolts, which is about 0.4 volts, which is reasonable for a diode. So let's go up to the next value, which would be, let's go up to 1. There we go. So at 1, we have 480 millivolts. So we're going to put these values in the chart, and we're going to chart it. So let's go up to 2 to show you it works on A. And we're at 2. We could probably, let's see if we can go down a smidge. Perfect. So we're at about a half a volt, 500 millivolts. Okay, so let's go all the way up. So let's go to 5. 5 is the maximum. So let's see when we get 5. Yeah, it's close enough. So we're at about 532 millivolts, reasonable. So we're getting a nice upward flow on our diode. And that's the way we would do this, and we'd mark it into our chart, and then we'd put it on our graph. Let's reuse our previous circuit. This is forward bias, and we want it reversed. So what we do to reverse the diode, go ahead and double click on it and flip vertically, and then make our new connections. And then we can put a reverse bias where it should be, and let's go ahead and start the circuit. There's our voltage on the circuit. There's our current, and here's our voltage. And we have 2.72 volts. So let's see if we can get down to half a milliamp. So let's bring her down, Shift A. You have to put on the circuit, otherwise it won't work. Let's go down about 20%. There we go. So we have half of an amp, and we're getting about 500 millivolts. This is reverse bias, so this guy is going to act as a zener. As we start moving up our current, we're 1.59, so our current should keep increasing until we get to a point where we're able to run it as a zener. 1.5. There's 2 volts. So our voltage, our curve is increasing. There's 2 volts. There's 3 milliamps. We're at 3 volts. Let's go to 4 milliamps. We're at 4 volts. And let's go up to 5. Here's 5 milliamps. We're at 5 volts. And let's go up a little more. And we're at 6. 5. Okay, let's just kick up our voltage a little bit. This is a 5.6. Let's see if we could get there. So I'm going to increase my voltage on our battery and restart it and see if we get to the 5.6. And we're at 9, almost 10 milliamps, and we're getting pretty close to the 5.6 volts. So we still got a ways to go before we get to the 5.6 volts. Well, what we can do, let's go ahead and kick it up some more. Let's go to 20 volts. See if we're going to get to it. And 5.6. We're getting pretty close to it, so I'm going to call this good.